out of sleep.
Yeah, like my dogs were horribly confused this morning. Like I let them out to go to the bathroom and they're like, "Hey, cup time," and they went to get back in bed. I was like, "No, sorry. Gotta go get your crate." Alright, so this is gonna look kind of daunting. It's really not. It's just a lot of notation. So this looks terrible. It's not. Today is the 11th, I believe. Alright, so we're gonna kind of parse our way through this again. It's not nearly as bad as it looks. It looks a lot worse than what it really is. So we've got, let f and g be two functions. Okay, so just normal functions, no big deal. So then we've got a sum, which would be f plus g, the difference, which would be f minus g, the product, which would be f times g, and the quotient, which is f over g. Those are going to be functions also. Okay, so if you start out with two functions and you add them, subtract them, multiply by, you still get a function at the end of the day. Alright, so then it says the domain, and here's the important thing. Or I should say, here's the thing that you can't just go, yeah, that makes sense. You really gotta keep this in mind. The domain is the intersection of the domain for the two original functions. So you look at, alright, what's the domain for just my first function? What's the domain for just my second function? And then you look at, alright, where do those two overlap? Because it's where they overlap that the domain for the combined function lies. So we're going to still be using those domains that we talked about a whole week ago. They're still coming back. So we're going to be looking at two pretty nice, easy functions and combining them, but because of the combination, the domain is actually pretty easy to find. So we're just looking at where do those two originals overlap. Alright, so how do you actually find the sum function? Well, f plus g of x just means take those two original functions and add them together. So combine what you can, and if you can't combine stuff, just have a plus sign sitting there. For a difference, f minus g of x, well that's just f of x minus g of x. Okay, one thing you do have to be careful about, when you're subtracting, make sure you subtract the whole thing. So if you've got multiple terms, probably going to be a good idea to put that in parentheses so you remember to distribute the negative. Okay, then f times g of x is just f of x times g of x. So you're just going to multiply those two original functions together. And then f over g of x for our quotient is just f of x over g of x. Alright, so here's the deal. With these domains, we said the domain for these, it's going to be the intersection of your domain from f and your domain from g. The only thing is with the quotient, it could have to exclude just a tiny bit more because now you're putting g in a denominator and you have to worry about where that's going to be equal to 0. So the domain for the first three, so the sum, difference, and product, always the same. If you get it right on one, you're going to get it right for all three. The domain for the quotient might be the same, or you might have a couple of extra exclusions. So it's going to at least have to exclude whatever you did before, and then you might have a couple more things that are going to make that denominator 0 that you have to worry about. So do be very careful when you're actually finding that intersection of your domains though, because like I said, it's the same for all three. So if you get it right for one of them, you get it right for all three. But if you mess it up for one of them, you're going to mess it up on all three. So really take your time when it comes to finding those individual domains and their intersection, because otherwise it's going to hit you in several spots if you make a mistake.
So let me try to make sense of this.
Okay.
So what we're trying to do here by finding the sum, difference, the product, and the quotient is that we're trying to find the domain that both the functions can fit in.
Not quite. What we're going to be doing is we're going to be finding these combined functions. So sum, product, difference, quotient, and then their domain is what will work for both of them.
Okay. All right. And
so it's more that we're trying to find this, and then we're also concerned about the domain as kind of a byproduct of it.
Okay. So then for restrictions, the only one that's really going to have restrictions is the quotient.
Okay. Yeah, the quotient, it's that it might have extra beyond what the other three did.
Okay.
Because for the other three, all right, what's my domain from F? What's my domain from G? What do they have that's the same? Whatever's the same is what we keep. But then, yeah, with quotients, because we're throwing a fraction into the mix, we do have to worry just a little bit about G of X. So, all right, is something else going to have to get removed because it could make our denominator 0. So sometimes it might have extra, sometimes it might not.
Click the guy.
So again, I know this looks really, really notationally heavy right now, but when we actually start working with the functions, they're not nearly as terrifying looking as all of this notation is. All right, so let's try doing this. All we're working with today is we're going to be combining these functions. So we're going to find f plus g, f minus g, f times g, f over g, and we're going to figure out, all right, what's the domain for each of these? But again, for those first three, thank you, domain's going to be the same. And then for that last one, we may have to exclude just a little bit more. All right, so our two functions here, we've got fx equals 2x plus 3, and g of x equals x minus 1. All right, so let's first worry about the domains for the individual functions. So what's the domain for f? Are there any x's we're not allowed to use?
No.
No, so what would the domain be? Right, all reals are negative infinity to infinity. Okay, so just for that little guy, it's going to be negative infinity to infinity. All right, what about g of x? G of x is x minus 1. What's its domain? All reals. All right, so now the important question. So this is our domain for f, if we want to use their notation, and the domain for g. Where are those two going to overlap? If we've got all reals and all reals, what do they have in common? Everything. So yeah, it's all reals.
Man, they are perfect for each other.
I know, isn't it great? All right, so the intersection for those two sets, it's going to be all reals. Okay, so pretty nice domain for that first combinations. So let's actually work with our functions a bit. So we're supposed to find f plus g. So what happens if we add those two functions together? So we're just going to take f of x and add g of x to that. So we got to simplify where we can. Can we simplify this at all?
Yeah.
Yeah, what can we do?
Combine the x's and all.
Right, yeah, we can combine our x's and then combine those integers. So yeah, we get 3x plus 2.
So that negative infinities all are gonna be for like all of them except for the fourth one.
It'll be for the first 3, and then for the fourth one we might have to exclude just a little bit more.
So you
yeah.
don't have to show any more work on it.
Well, I'm getting there. We have to put the domain for each of them. I know, so much more writing. So yeah, the domain for this guy, negative infinity to infinity. All right, so then next we're looking for f minus g. So we're going to take f and subtract g. And here's where I said you might want to put that second one in parentheses because don't forget we're subtracting the whole function. So if we take f minus g, we would distribute their negative and say, all right, that's really 2x plus 3 minus x plus 1. So yeah, if we combine our like terms again, we get x plus 4. Okay, and what's the domain for that function? All reals, once again. Okay, so then we want f times g. Well, that just means take our function f and multiply it by our function g. So what are we going to have to do here to multiply these?
Boil.
Yeah, we got to boil those out. So let's see, we'll get 2x squared minus 2x plus 3x minus 3. Combine like terms just a little bit. And we'll get 2x squared plus x minus 3. What's our domain? All reals. Alrighty, so then we've got one more. We need to find f over g. Okay, so that means we're going to take our function f, put it in the top of the fraction. Take our function g, put it in the bottom. Okay, is there anything we can do to simplify that function?
No.
Nope. Not a single thing. So usually when you're looking for that quotient, the only thing we're going to be worried about is, all right, we made a fraction, do we have a square root in the denominator? Because we're not going to be allowed to leave that. But for the most part, f over g, you don't have to do much work to actually find that combined function. But we do have to worry about our domain a little bit more. So is there any value, excuse me, that we need to exclude here?
1.
1, exactly. So yeah, we got to worry about 1 because it would make our denominator 0. And we know bad things happen when we do that. Yeah, if we exclude 1, we're good to go.
Is there another way to write that?
Yeah, you could do set builder, but it's just so much nicer in interval notation.
But it's so much easier.
Oh, but it just looks so elegant and pretty.
Maybe they're good at writing infinity signs, but not.
The
Better
more
writing
practice, the
squiggles.
better the look. Because usually people like used to type squiggles and then they see this and then go, all right, I can deal with the squiggle. All right, so any questions on first bunch here? Yes, sir.
So, with your question, what happens if it's like a more complicated problem and you can like take out a common factor from both of those and say it's like, you get 2 on the bottom and 4 on the top, can you cancel these out? I don't know.
Oh, yeah, so you're saying like if you could take out a GCF and cancel, you could. But yeah, here, not a whole lot we can do. But yeah, so say this had been like, yeah, if you could factor out 4 on top, 2 on the bottom, you could reduce them. But that's about it. All right, anything else with this first guy here? All right, how are we feeling so far? Any 1s, 2s, 3s, 4s, 5s? All right, so these are about as nice as our functions are ever going to be. Remember. All right. So now we're gonna look at some that are just a little bit squirrelier.
So is this about as hard as they can get, or is
Not
that
quite.
still
I would say this is like medium.
joys?
Oh, similar. All right. So we've got f of x equals the square root of x, and g of x equals x minus 4. Alrighty, so again, let's worry about our domains first so we don't have to worry about that later. So looking at f of x, what's our domain going to be? It can't be negative, so what does x need to be?
Positive.
Okay, or
Greater than or equal to 0.
greater than or equal to 0. Yeah, it could be 0. So the domain for f is going to be from 0 to infinity. All right, what about g? All reals, yes, our favorite one. Okay, so now we gotta figure out what is their intersection.
0 to infinity.
Yeah, because if we're looking at 0 to infinity and just everything where they overlap, well, 0 to infinity. So if you're having a hard time seeing where they overlap, remember number lines can help you out some. Alrighty, so we've got our intersection, which means we know what our first 3 domains already are. Woohoo! So let's start finding those combined functions. So we take f plus g, we would get, let me try that again, the square root of x plus x minus 4. Can we do anything?
No.
No. So that one's done. All right, so then what's its domain? 0 to infinity. Okay, then we want f minus g. And that looks nothing like a minus. Let's try that